In this video, we'll focus on the calculations of the parallel circuits. Only another video where we discuss the series circuit calculations. So for this video, we'll focus on parallel circuits. I level this example. This resistor and this resistor is connected in parallel. Parallel are a branch, but for a series normally one path, one, something like this one. So normally something like this one, normally a series connections because in over one. But for this one, normally parallel because this resistor is parallel to this resistor. So we're going to focus on the calculations that involve this kind of circuits. But before to discuss the examples, I'll discuss the important things for the parallel circuits. Let's say for example this circuit, and then let's say this one the resistor 1 and then this one the resistor 2, and then this is our cell. Let's say 9 volts, and then this is a positive and then this is negative, because positive re tseba ka line e telele and then negative re tseba ka line e nyane. So more le positive and then more le negative, and then re tseba the conventional current is from positive to negative. This means current it will move ka this direction, ya tsamaya this direction, and then ya fihla at this point. So this current engwe it will ya at this resistor, and then engwe ya at this resistor, and then this current ya tsamaya ya fihla at this point, and then current ya this one ya fihla at this point, dia kopana here. So dia tsamaya again ile total, dia boela back to the source. Let's say if current is 3 amperes for this circuit, this means this 3 amperes ga tsamaya ga fihla mo yo splitter engwe yo ya mo this resistor, and then engwe ya mo this resistor. So current divide. So every time ge re bolela ka the current divider for parallel circuits, I explain something like this one. Let's say if more than 3 amperes current, this means more can ya 1 amperes and then more ya 2 amperes. So this current is splitter, and then dia kopana gape mo dia ba 3 and then dia tsamaya together. So parallel circuit current divide. And then ntolo re tshwantse o itsebe botlhokwa again gore V parallel is equals to V total is equals to V1 is equals to V2, meaning voltage ya the parallel circuit ya lekana. Ge ile gore re na le 9 volts, this means this resistor voltage ya gona e tlo ba 9 volts, even this one it will be 9 volts. So always the voltage of the parallel circuit dia lekana. So this information is very important. And then I total lekana le I1 plus I2 plus I3. Ela ola go rona le di resistors tse kae in parallel. So ge le rona le di resistors tse 3 in parallel, era gore o tlo add the current ja those resistors and then dia fa I total. This is because this current is usually ile total, and then ya fihla at this point ya splitter engwe ya godimo engwe ya ka fase. So that is why I total ile kana le I1 plus I2. If re shumisha this example ya resistors tse 2, I total it over I1 plus I2. This makes sense because these 3 you splitter engwe yo ya mo this resistor, and then current engwe ya on this resistor. So that is why I total ile kana le I1 plus I2 plus I3, so on and so forth. Ela ola go rona le di resistors tse kae tse parallel. So V parallel ile kana le V total is equals to V1 is equals to V2. Ela ola go rona le di resistors tse kae in parallel. Ge ile re ona le resistors tse 3 in parallel era di voltages tsa ona go fela di a lekana. So this information is very important. And then another thing, R total. So ge re calculate R total re nyaka the total resistance ya di resistor tse le in parallel. So 1 over R parallel, this R parallel ke total resistance ya rena. So 1 over R parallel is equals to 1 over R1 plus 1 over R2. Ge le rona resistance tse 3 e tlo ba plus 1 over R3. But rena re tla ba re nyaka R parallel, not 1 over R parallel. Let's say if o kry-a answer ya gago ya, let's say 4 over 2, and then re nyaka R parallel. This means R parallel is equals to 2 over 4. O tlo find out the inverse. O tlo flip this number wa phethola. So ya ba your R parallel, and then your R parallel ya ba your R total. But ge o na le resistor tse 2 fela, o ka kgona go šomiša this formula, where R1 times R2 over R1 plus R2. This is only if o na le resistors tse 2 fela. But ge o ka ba le resistors tse 3 or more, o gapeletša go šomiša ya 1 over R parallel. So ge o na le resistors tse 2, o šomiša this formula, or ya 1 over R parallel. It's all up to you. But I think this one is very easy and straightforward ge o na le resistors tse 2, because after finding your answer, o tlo ngwala answer ya gago ntle le go find out the inverse, because this is R parallel ke the resistor e re nyakago, ke yona the R total ya these parallel resistors. And then again re na le current divider rule. Remember, we current ya divider for the parallel circuits. So ge re se re na le current, let's say re na le current ya total, re tseba re this current yo divider here. So o ka kgona go tseba gore on this resistor o ya current ya bokae, and then o ka kgona go tseba gore on this resistor o ya current ya bokae, wa šomiša current divider rule formula. So this formula, let's say o nyaka go calculate current ya resistor 1, o tlo re I1 is equals to R2 over R1 plus R2 times I total. And then let's say we have I2, current of V2 lekana le R1 over R1 plus R2 times I total. Kwa kgono lemoga gore ge re nyaka I1 re šomiša resistor ya R2 as numerator. So ge re nyaka I2 re šomiša resistor ya R1 as numerator. So o šomiša resistor ile re parallel to that current ya resistor we nyakago. So this formula re bitša gore ke the current divider rule. And another formula ile is important ile re tlo ba re šomiša ke this one, R is equals to V over I. Remember previously ge we define resistance we šomiša this formula. So this is a resistor, this is voltage, and this is current. So o ka kgona go calculate a resistor, voltage, and current. Then ge o nyaka voltage, e ra tlo dira V subject of the formula, e ra V is equals to IR. And then ge o nyaka I, e ra tlo ba le I is equals to V over R. But remember gore ge o nyaka V total, e ra re o tlo šomiša current ya total, then o šomiša resistor ya total. And then ge o nyaka V1, re la gore o tlo šomiša current ya V1 and resistor ya V1. And then ge o nyaka I total, ra tlo ba le I total, V total, and R total. And then ge o nyaka I1, ra le tla ba I1, V1, and R1. So they are correspond. If it's I2, it will be I2, V2, R2. So ke di formulas tse re tlo ba re di šomiša for these problems. Make sure ya gore o tseba all those formulas tše be re tlhalosa here, and then o tseba le this one, and then from here re tlo treat some examples. Lebelela this circuit diagram, o ka kgona bona gore mo re na le parallel connection, because ka kgona bona gore this resistor and this resistor di parallel. And then re tseba gore the first thing ge o nyaka wa check these questions, lebelela your positive and your negative terminals. Re tseba gore line e telele ke positive and then e nyane ke negative. This means current e tsamaya in this direction, because current e move from positive to negative. So current yo tsamaya in this direction ya fihla here, and then e nngwe ya tsena at this resistor, and then e nngwe ya feta mo ya tla at this resistor. So they are divider because of the parallel circuits. Every time re ka bona current divider e ra gore o na le the parallel circuit. So this current ya this resistor yo tsamaya here, and then ya this one le yona ya tsamaya, and then they are kopana here. So ge di kopana mo ke di a tsamaya again e le full ya boela here. Our part A question ere, what is the total voltage of the circuit? O ka kgona bona re mo re na le a cell, so re na le a battery. This voltage on this battery always ke your total voltage, because ke the voltage le re tlo supply for this circuit. So our answer for part A re la gore V total is equals to 12 volts. And then part B ere, calculate the total resistance of the circuit. Because more na le the parallel, e re la gore tlo ba le 1 over parallel is equals to 1 over R1 plus 1 over R2. Therefore re tlo ba le 1 over 6 plus 1 over 4, and then 1 over 6 plus 1 over 4 ke 5 over 12. But re nyaka R parallel, not 1 over R parallel. Era re tlo dira the inverse, re tlo phetola this number. Therefore R parallel re tlo ba le 12 over 5, and then 12 over 5 ke 2.4. So re na le 2.4 ohms ke di units tša resistor. So our R parallel ke yona the R total, 2.4 ohms. Or o ka dira in this way, because re na le di resistors tše 2 fela, o ka dira in this way, where R parallel is equals to R1 times R2 over R1 plus R2, because this formula re šomiša ge re na le di resistors tše 2 fela. So tlo ba le 6 times 4 over 6 plus 4, and then it will fa 12 over 5, and then it's the same answer, which is 2.4 ohms. So it's all up to your shumisha which formula, but I think this one is very simple ge o na le di resistors tše 2. Part C ere, what is the voltage drop across each resistor? O ka kgona le mo gore mo re na le the parallel circuits, and then ge re na le a parallel e re la gore V total le kana le V parallel, so e ra gore voltage is the same everywhere. Therefore e ra re voltage ya 6 ohms ke 12 volts, and then voltage ya 4 ohms le yona ke 12 volts. So voltage is 12 volts, even this one is 12 volts, because voltage is the same in parallel circuits. So a re lebelele part D. Part D, it calculate the current across each resistor. re ka shumisha this formula ya I is equals to V over R. It was from this formula R is equals to V over I. Re define a resistor, and then because re nyaka current ya each resistor, re tlo re I 6 ohm, because re nyaka current ya this 6 ohm le ya this 4 ohms. So re tlo shumisha voltage ya 6 ohms, and then re shumisha le resistor ya 6 ohms because re nyaka current ya 6 ohms. So re tlo ba le 12 over 6, because voltage ya 6 ohm is 12 volts. Voltage is the same everywhere, and then 12 divided by 6 is 2. So our current is 2 amperes. Yeah, this 6 ohms, and then re nyaka ya 4 ohms, re tlo ba le I ya 4 ohms is equals to voltage ya 4 ohms, and then resistor re shumisha ya 4 ohms. Therefore voltage is the same, re tlo ba le 12, and then R ya ba 4, and then 12 divided by 4 is 3. So this means current yeah this 6 ohms is 2 amperes, and then yeah this one is 3 amperes. So our answer is part D. Our level part E. Part E, calculate the total current of the circuit. Remember, for parallel circuits, I total lekana le I1 plus I2 plus I3 ela la go rena le di resistors tse kae. And then remember this current re kry gore ke 2 amperes, and then yeah this one re kry gore ke 3 amperes. So this means re tlo ba le I total is equals to I1 plus I2 ke this current and this current. Remember this current di kopana here again at this point, and then di a tsamaya ya ba total. This means this current e tswela ile total ya 2 amperes ya tsena at this resistor, and then ya 3 amperes ya tsena at this resistor, and then di a kopana again here, so di a tsamaya together. So that is why I total is equals to I1 plus I2. So it will be 2 plus 3. Therefore our I total is 5 amperes. And then ge o rata o ka shumisha this formula ya I is equals to V over R, this one, but because re nyaka I total o tlo shumisha V total over R total. Our V total ke 12 because the voltage is the same, so o tlo ba le 12 divided by R total, and then R total re kry-ile gore ke 2.4. Therefore 12 divided by 2.4 it will fa 5, so it's the same thing. It's all up to you when shumisha which formula. And then for this circuit o ka kgona bona gore re na le di resistor tse 3, and then these resistors di in parallel. O ka kgona bona gore this one and this one in parallel, and then the parallel to this one again. So re tlo dira the same thing. O ka kgona bona gore this is our positive and then this is our negative. This means current you move at this direction ya tsena at this resistor, and then e nngwe ya tsena at this resistor, and then e nngwe ya tsena at this resistor. So this current ya tsamaya at this point, and then yeah this one di a kopana here, and then yeah this one ya fitla here, and then this di a tsamaya together, and then up until this point. So because the current divide, this means this is the parallel circuit. Now our level our part A, calculate the equivalent resistance of the circuit. if re nyaka the equivalent resistance ba no rela gore calculate the total resistance of the circuit. Re tseba gore R parallel ke R total, so re tlo ba le 1 over R parallel is equals to 1 over R1 plus 1 over R2 plus 1 over R3, because re na le resistor state 3. Re tlo ba le 1 over 7 plus 1 over 15 plus 1 over 12. So re ka pressa calculator e tlo fa 41 over 140, but rena re nyaka R parallel, not 1 over R parallel. This means re tlo find the inverse. Re tlo ba le R parallel is equals to 140 over 41. So re tlo flip this number, re petrol. So 140 over 41 er for 3.41. So this is our R parallel, which is R total. So we can press this number ka calculator, and then the answer you agree, and then wa level a calculator wa press x to the power minus 1 ke inverse, so it will offer straight this answer. Now our level part B. Part B, calculate the current through the circuit. The current through the circuit, the total current of the circuit. And then that's for I total I1 plus I2 plus I3. But o ka kgona bona gore ga re tsebe current this one and this one. So this means re ka se kgone go šomiša I total is equals to I1 plus I2 plus I3. Re tlo šomiša this formula ya I is equals to V over R. And then because re nyaka I total, re tlo šomiša V total, and then ra šomiša R total. Our V total is 20 volts. Re tlo ba le 20 over, and then R total re kry-ile gore ke 3.4, because our R parallel ke yona R total. And then our answer is 5.88 amperes. So this is our I total. Now our level part C. What is the voltage drop across each resistor? Let's worry for parallel circuits. V total V parallel. So voltage is the same everywhere for the parallel circuit. This means voltage is 7 ohm 15 ohm 12 ohms. So our all in all is 20 volts, because voltage is the same for the parallel circuits. So this is our part C. Our level part D. What is the current through each resistor? So banyaka current ya this resistor, and here this resistor. So re ka šomiša this formula. I is equals to V over R. And then because re nyaka current ya each resistor, R to make 7 ohms. I 7 ohms is equals to V 7 ohms divided by R 7 ohms, because always they correspond. I will calculate a current ya 7, voltage over 7, resistor over 7. Therefore globally 20 divided by 7. So 20 divided by 7 over 2.857. 2.857. Remember our rounding offs allow like the instruction about fill yon. If question in your question paper area, your answers must be in 2 decimals. We ngwala o ya ka the instruction. So nna ke no e rounda the way ke nyakago. So this is our answer. The current ya 7 ohms. A re lebelele ya 15 ohms. Re tlo shumisha voltage ya 15 ohms, and then ra shumisha R ya 15 ohms, and then voltage is 20 volts because 20 voltage is the same. And therefore 20 divided by 15, 1.33. So ke current ya 15 ohms, and then R level layer 12 ohms. I 12 ohms is equals to V 12 ohms divided by R 12 ohms. Therefore globally 20 divided by 12, and then 20 divided by 12 get 1.66 amperes. So this is our answer for part C. This is our answer for part D. Calculate current ya each resistor. Calculate current ya 7 ohms, 15 ohms, and 12 ohms. So from this, I'm going to prove our current is correct. Remember our I total I1 plus I2 plus I3. Therefore, can we check current ya this resistor and this resistor and this resistor, what you add together, so you do this answer. The also answer is straightforward, but the answer is closer to 5.8 because rounding offs the answer that's one. So but it offer 5.8 something. And then that's it for this question. This problem area, given that the current of the circuit is 6 amperes, so what feel total current ya circuit, and then on this circuit this is our positive and then this is our negative. This means current is amaya in this direction because current move from positive to negative. So this current it was amaya, and then ya splitter, meaning ya divider, engwe ya tsena mo go 4 ohm resistor and then engwe ya tsena mo go 8 ohm resistor. So this current and this current, this one in this direction, and then they meet them again, and then they will back to the source. This means this current is divider, and then for parallel circuits, current always a divider. This means this resistor ya 4 ohm layer 8 ohm do share this 6 amperes. And then question area, calculate the current passing through 4 ohm resistor and 8 ohm resistor. Re nyaka tseba gore 4 ohm resistor yo shumisha current ya bokae, and then 8 ohm resistor yo bal current ya bokae. This question o ka ilebelela o ka kgona bona gore the easiest way o ka shumisha the current divider rule formula. Ge re nyaka go find I1, re tlo re I1 is equals to R2 over R1 plus R2 times I total. Let's say this resistor ke resistor 1, and then let's say this one ke resistor 2. So finding I1, R2 ya rena tlo ba 8, and then R1 ke 4. So rena le 4 plus 8, and then our I total is 6. Therefore 8 divided by 4 plus 8 is 12, and then times 6 it will for 4. nka o press a calculator. The answer is 4 amperes. So ke current ya 4 ohm resistor. Re šomišitše the current divider rule. And then ge o nyaka o kry-a current ya this 8 ohm resistor I2, o ka šomiša again the current divider rule, or I2 is equals to R1 divided by R1 plus R2, and then times I total. Remember gore ge re nyaka I1 re šomiša resistor ya parallel to yona, and then o ka kgona bona gore resistor 1 parallel to resistor ya V2, which is 8. So ge o ka substitute o tlo kry-a the answer. But as for me, I think this problem is very easy and straightforward, because re tseba gore for parallel circuits I total le kana le I1 plus I2. Remember this current ya divider e nngwe ya mo and then e nngwe ya mo ke. So that is why I total e le sum ya this resistor and ya this resistor current ja yona. And then ba re file gore I total ke 6 amperes, and then I1 re kry-ile gore ke 4. So finding I2 it will be straightforward. This means I2 it will be 6 minus 4, therefore it will be 2 amperes. I think this one is really straightforward, because ge ile gore this current mo go tsena 4 amperes, it's obvious era gore for this resistor go tsena 2 amperes because current ya divider. So this is our answer. I2 is equals to 2 amperes. Ge o rata ka šomiša this formula o tlo kry-a the same thing. So for I1 re kry-ile gore ke 4 amperes, and then this one re kry-ile gore ke 2 amperes. It makes sense because 4 and 8 o ka kgona bona gore 4 ke 2 times 8, so that is why I1 ya rena re file gore ke 4, so which is 2 times 2, so it makes sense. And then another thing ya bontšha gore it makes sense, always o tshwanetse o tsebe gore resistor e nyane e tšea current e kgolo, and then resistor e kgolo e tšea current e nyane. This is according to Ohm's law. So ge o ka ba le the parallel circuit in this way, o tshwanetse o tsebe gore resistor e nyane e tšea current e kgolo, and then resistor e kgolo e tšea current e nyane. So it makes sense. Resistor e nyane ke 4, and then e tšere 4 amperes, and then resistor e kgolo ke 8, and then e tšere 2 amperes. So that's it for this problem.